So we've worked so far with median as a measure of central tendency. The other two are mode and mean. Today we're going to focus on mean. We're not really going to talk about mode because it's not particularly useful for us this unit. But mean is really important. And you guys have calculated mean many times in your math classes over the years. So I'm just going to remind you that mean is that average, right? When we find the average of something. You guys have done it a billion times. You add them all up. You take the sum of the values in the data set. And you divide it by how many there are. Okay, so that's finding the mean. Okay, so in this learning target today, we're going to work a lot with the mean. It's going to become pretty important. So let's take a look at the first example. Caleb and Kim have bowled 3 games. Their scores are shown in this chart below. So Caleb scored 151, and then 153, then 146. Kim scored 122, 139, and 189. So A says find Caleb's average score. So to find the average, all we have to do is add 151 plus 153 plus 146, and then divide it by 3 because there's 3 total values. Okay, now you're going to really need you can't do this learning target today without a calculator, especially a graphing calculator. It's kind of impossible. So as we're going along today, if you want to pause and come borrow one from a friend or from me, that might be particularly useful today. So I'm not going to do this in my head. 151 plus 153 plus 146. Hit enter first, then divide it by 3. So I end up getting 450 divided by 3 equals 150. So Caleb's average is 150. All right, now we're going to do the same thing, but we're going to do it with Kim's average. So 122 plus 139 plus 189 divided by 3. So put it in my calculator. 122 plus 139 plus 189. 450 also over 3. So both their averages are the same. So let's kind of talk about what that average score means and how it compares to what their actual games points were. Okay. So, first of all, they were the same. Just said that. Let's write it down. So the next question asks, who's more consistent? Now, the word consistent means like you do the same thing over and over and over and over again. It's the same. It doesn't change very much. So if I go up to Caleb and Kim, I'm noticing that Caleb got 151, 153, 146. Those are all very close to each other. Like, they're only off from 10 to 15 points. If I look then at Kim's score, she goes 122, 139, and then jumps all the way up to 189. That's not consistent. Like, she's kind of bowling the same a little bit 1 and 2, and then all of a sudden she scores a 189. That's kind of odd. So if I have to answer this question of who's more consistent, I'm definitely going to say that Caleb is more consistent. He doesn't have just like a random score somewhere. Letter E, Caleb's scores are farther from or closer to the average than Kim's. Caleb is definitely closer to the average. Look, 151, very close to 150. 53, close to 150. And 146 is close to 150. But Kim, she's got a 122 and a 139, which aren't as close to 150 as Caleb. And especially 189 is not close to 150. So Caleb's scores are definitely, his scores are definitely closer to the average than Kim's. So now they bowl a 4th game, where Caleb scores a 150 and Kim scores a 175. So they've got bowled 4 games now. Now, without doing any math, if Caleb scores a 150 and the average is 150, then his average stays the same. And you guys have seen that. If your grade in the grade book is an 80% and you get an 80% on your test, your grade doesn't change. It stays an 80%. For your average to change, you have to either get more than your current score or get less than your current score. So when I look at Kim, and she scored 175, and the average is 150, then her average will increase. This is how grades work too. When you guys ask, oh, if I get this on a test, what will happen to my grade? Well, if it's higher than your average, the average is going to go up. That's how averages work. Okay? The next question says, does the game 4 affect the consistency of their scores? Well, not really. Caleb is still saying the same. Caleb didn't, his consistency didn't change. So, no. Like, Caleb is still kind of doing the same thing. But Kim, her average increases, and that doesn't really, her consistency hasn't been consistent. So it doesn't affect really Kim either. Kim, that went down to 175. She had scored a 189. It didn't go back to 122. Her scores are all over the place. So it didn't affect either of their scores in terms of consistency. The next two questions talk about, is the average an accurate representation of their bowling? Meaning, if I tell you their average, if I say like, John has a 75% in math, and you look at his grade book and all of his scores are around 75, then yeah, the average would be a good representation of his overall, all of his grades. So in terms of Caleb, yeah, because his average, the 150, is near all his scores. On the other hand, you could be the type of student that maybe scores a 65% on your first test and then like a 95 on your next test, and your average would be somewhere around a B. Well, that B doesn't match the A and it doesn't match the C, so it's not really representative of your scores. So that's kind of where Kim is at. That 150 does not represent her scores. Her scores are not near 150. Okay, so for Caleb, the average is super helpful. For Kim, it doesn't really describe what kind of bowler she is. If I said Kim's average is 150 and then you saw her actual game scores, you might be like, what? Wait a second, that doesn't make any sense. Okay, so sometimes the mean is a good way to look at data and sometimes it's not. Okay, so let's take a look at how I want you guys to be able to calculate things in a data set. This is kind of a review. I want you to be able to now include the mean in what we've been doing so far. So we've been able to calculate the median, maximum minimums of a data set, the mean of a data set, the range, and the quartiles. So for this first one, let's go ahead and calculate all of those things. So I'm going to reorder the data from least to greatest. So 70, 71, 72, 73, 74, and 96. I'm going to calculate the median. That's these two guys right here. So the median is actually 72.5. So there's my median, 72.5. My maximum is 96. My minimum is 70. And therefore my range is going to be 26 because 96 minus 70 is 26. I'm going to find my quartiles. This is just like your box and whisker plots. So this is my first set. This is my second set. So this 71 is my Q1 and 74 is my Q3. So first quartile 71, third quartile 74. My IQR is 3 because 74 minus 71 is 3. And now the next thing we just added to this was finding the average. So you're going to add them all up. 70 plus 71 plus 72 plus 73 plus 74 plus... Now, you don't have to write all this down. When you go ahead and calculate mean, just plug it in your calculator, okay? When you plug all of this into your calculator, you do get 76. So 76 is my mean, okay? So now I want you to try this on your own. For this one, for Elise's problem with her money, you're going to get some decimals, okay? Whenever you get decimals, please round to the 10th, okay? Always, always, always for the learning target, round to the 10th. Okay? Go ahead and try this on your own, and when I unpause, I'll show you the solutions. All right, here are the values that I got. I might have made a mistake, like I often do, so please double check. If you think I'm wrong, come talk to me. I'm human. I use my calculator same as you, and I don't always get things right. So this is what I got when I calculated this data set, so hopefully you guys got the same thing. We're going to move on to something really advanced. This is not something freshmen generally learn. This is something you don't see until you take something like AP Stats here at West. So if any of you guys get to that point and you want to take statistics, this is a really tough thing to learn. So it's called standard deviation, and I bet you guys have heard this before. Someone said it, your standard deviation, you're this far from the mean, the average. Standard deviation basically tells you distance between data points and the mean. So you've got all these data points, and you've got your mean. Standard deviation says, hey, look, this data point is this far away from the mean on average. So it's like kind of taking an average of an average. It's very strange. So I'm going to go ahead and write that down for you so you can, have that. So it's your average distance between data points and the mean. This is kind of hard to imagine. If I have a data set like 3, 7, 8, 9, 11, the range is your distance between 11 and 3, right? Your range would then be 7 because range describes a distance. The standard deviation also describes a distance, but it's describing it from the total mean of all these values. So it's not very easy to see because you first have to calculate the mean and then calculate all the little distances between that and figure out one value. So it's very similar to range. It tells you that the standard deviation tells us how data points are spread from the mean, whereas range tells us how the data points are spread from the median. Whoa, I don't know how that just happened. Let me fix that. Range tells us then how data points are spread from the median, which is what we've been working with, right? Finding that range, subtracting that first and last value. So let's take a look at this, how we find standard deviation the hard way. It's really a terrible process. So I'm going to show you it once so you can kind of get an idea of what goes into this calculation. So here's our data set. It's all of these values, and your first step is always to find the mean of this data set. So I've kind of already written it out for you. You add up all of the values and divide it by how many there are. There's 20 values here. Now when you add all of this up in your calculator, you end up getting 145. When you divide 145 by 20 to find the mean, you get 7.25. Okay? So I've just kind of saved us some time by doing that because it's a big data set. So our mean is 7.25. Okay, first step, mean. The next step is this really terrifying table. Okay, standard deviation always requires a big table because you're going to have to find a lot of little values. Remember, you're finding distance from the mean. Okay, so in this column are all my data values. In this column, oops, sorry about that. In this next column, what you have to do is you have to subtract all your data values from the mean. So we're going to subtract data from the mean. So I'm going to take my first data set 2, I'm going to subtract 7.25. Take the next data set 3, subtract 7.25. Okay? So when I do this, I'm going to get a bunch of little values. So when I go into my calculator and do 2 minus 7.25, I get negative 5.25. It's okay to get negative numbers here. When I do 3 minus 7.25, I get negative 4.25. Okay? So you do that for the entire table. You just take all the data points and subtract 7.25. The 3's are all the same here, so I know that this is going to be negative 4.25, this is going to be negative 4.25. Cool. So now, you're going to do the rest of these in a second, but now that I've kind of started this process of subtracting the mean, once I get all of that column done, then the next step is super weird. The next step in this column is you're going to take the square root of those values, which is really strange. Okay, so I've got this negative 5.25. I'm going to take this and I'm going to take the, not take the square root, I'm going to square it. Sorry. We're going to square that value. So when I go to my calculator and I put in parentheses negative negative 5.25 parentheses, and I square it like this in my calculator, I'm going to get this 27.5625. Always round to the nearest tenth in this target. So I'm going to get 27.6. When I do the next one, I'm now going to take negative 4.25 and I'm going to square it. So negative 4.25 parentheses squared, I get 18.1. Okay, so that's the process for this entire table. So what I'd like you to do, and this might take you some time, is I'd like you to practice filling out this table. I'm going to go ahead and pause and fill it out for you. So I really would like you to try this process. I know most of you are just going to pause and write it in. That's up to you, but I would like you to try at least the first like 10 values. Okay, after that, if you want to copy them in, you feel like you get it, I'm totally okay with that. So I'm going to go ahead and fill all of these in when you unpause. Okay, so you get the idea. Okay, so here's my completed table. I've filled in all of my values that I've gotten. Notice these arrows I've drawn because basically you're putting in you're putting in 7.25 for all of the ones in that box. So I'm going to go ahead and scroll, tell you these values you should get. If you need to pause to check your work, go for it and pause. So these are all the values we need to calculate standard deviation. Now the crazy part, because that wasn't the crazy part of this. Here comes the crazy part. The crazy part is now what you're going to do is all of these values in this right column here, you're going to add, leave that in green, you're going to add them all up. Add up all the squares that you got here, which is craziness. So I'm going to go ahead and tell you that when you add all of these values up, you end up getting a total, okay? And that total, when you add everything up, is going to be 245.75 when I add up all of these. So basically what I'm saying is I'm going to add up this, I'm going to add this, add this, add this, add this, and get one giant total at the bottom. When I do that, I end up getting this thing right here, 245.75, okay? Now, okay, 245.75, you're going to find the mean of that. So you're finding a second mean. You're finding a mean of all those squared distances. Okay, so there's 20 data points, so you're going to do 245 divided by 20, and then you're going to get 12.3. Now we're not even done yet with this little number right here. Okay, so this is your mean squared deviation, right? That's what this is, your mean squared deviation. Then you take the square root of that thing, of 12.3, and you get 3.5. That is the value we want, that 3.5. So this deviation means that if your mean of this data set, and we already decided that the mean of this entire data set, the mean of this data set is 7.25. That's my mean of the whole data set. So this is saying that data points are on average 3.5 points away from 7.25. That's our standard deviation. And I'm going to tell you right now, I'm never going to make you do this process I just showed you. I wanted to show you the process to show you how complex it is, to show you that this value is not easy to find, okay? But it has meaning, okay? It's describing distance between the mean and data points. So I'm going to show you why calculators are amazing. So we have cool technology that helps us find this standard deviations for us. So what we're going to do is we're going to learn how to do it in the calculator. So here are the steps for this. Step 1, you're going to go to your calculator, and you're going to press the Stat button. This little menu is going to pop up. It says Edit. And what we're going to do here is I'm going to go back to one of our original data sets we had. I'm going to go back to, like, let's say this guy, the UTRI right here. Let's take a look at this data set for an example, okay? So the first step, you don't have to flip your page. You can leave it on your steps, on your notes. I'm just going to reference this right here. So we're going to go to Stat on the calculator, and then you're going to hit Enter on Edit. So we're going to click Enter on Edit, and you're going to see this list of these lists here. If they're filled with something, just hit double-click Clear. And now we're going to input our data. So we're going to hit 75 and then hit Enter. So each data point you plug in, hit Enter. 97, hit Enter. 360, hit Enter. 84, Enter. 119, Enter. And 100, Enter. So you put all of your pieces of data in there. Okay. Once you get all your pieces of data, you're going to hit Stat again. Okay, Stat button again. But now you're going to scroll over to calculate, because now we want to calculate some stuff, right? I want to find out what the standard deviation is. You get all these crazy things in your menu, but you're just going to stay on one that says one variable stats, and you're going to hit enter. This thing is going to look like it cleared your screen. It says one variable stats, and it's cleared. Go ahead and hit enter again. So you hit enter twice. And now you get all of this information right here, okay? So, interesting thing to note is that this first thing, this X with the hat on top, that is your mean. So notice that if I highlight to here mean, do you see how this says 139.16? That's the same as 139.2. So the calculator mean for us, okay? Other thing interesting to note, this S of X guy, so this S of X, and I'm going to put this on your other paper, that stands for your standard deviation. So in this particular problem, your standard deviation, it's right here, SX is 109. So in this data set, your standard deviation is 109. But wait, there's more. If you scroll down, you're actually going to get this 5-value summary that we've been looking for. Notice, min of X is 75. Here, min is 75. Your Q1 is 84. Look at that. Your Q1 here is 84. Your median, 98.5. Median, 98.5. Q3, 119. There we go, 119. Okay, and it even tells you your maximum. So the calculator tells you all this stuff I've been making you do by hand. Now you might be mad at me right now, but I think it's really important that you understand where these 5 points come from and where standard deviation comes from. Okay, so I'm going to go ahead and put a little bit of help in here for you to help you remember what these things are. So when you get X with a hat on it, that's your mean value. When you see XX, that's your standard deviation. And it gives you that 5-point summary if you scroll down. Okay? So what I'd like you to do is I would like you to try to find the standard deviation of this data set. Okay? Plug all that stuff in, and if you want to be extra cool, find that 5-point data, the Q1, min, max, Q3, and your median. Okay? All right, go ahead and pause. Find your mean. Find your standard deviation with your calculator. Okay, and if you want my help, come up and ask. I'm here. Okay, these are the values you should have gotten. You should have gotten your mean of 73 and a standard deviation of 2.9. And then here's your 5-point summary. Max 79, min 68, Q1 71, Q3 75, and your median was 73. If you did not get these, you probably put something in your list wrong. Please come check and I can find your mistake. Okay? On your practice, please pay close attention. On your practice, I want you to do even numbers by hand, and I'd like you to do even problems by hand, odd problems with your calculator. Okay, if you're the ones you do by hand with standard deviation are like 5 values. It's not very long, and I can work on those with you. So there aren't very many that I have you do by hand. It's not like the one in the video where it's super long. Okay, so just pay really close attention to that, and good luck.